In today's lesson video for day 8.4, we are going to be talking about area and perimeter in the coordinate plane. Now, you should remember a lot of what we talk about with area and perimeter from the previous unit, Unit 7. We talked about these formulas. So, as a couple of reminders, remember that perimeter is just the distance around the edge of a shape. Okay, for polygons, you can just add the sides or multiply opposite sides by 2 if there are congruent sides like that, but you're adding up the total number of sides. For circles, we use circumference. Remember, circumference is 2 pi r, where r is the radius of the circle. Okay, so for example, we have a parallelogram here. Remember that opposite sides of a parallelogram are congruent. So DC is 15 and AD is 8. So the perimeter is just the sum of those sides, or there are two 15s, so I could think of that as 2 times 15, plus there are two 8s, so 2 times 8. And then if we just simplify, 2 times 15 is 30, 2 times 8 is 16, and if I add 30 plus 16, I get a total perimeter of 46 units of measure. Okay, so perimeter is just the sum of the sides. Area is the flat area space taken up by a two-dimensional shape, and it's measured in square units. So we're going to use the area formula for whichever shape we're using. So remember, we had things like area of a rectangle was length times width. Okay, area of a parallelogram was just base times height. Area of a triangle is 1/2 of base times height. Area of a circle is pi r squared. Maybe even we would need to use the area of a trapezoid. Area of a trapezoid was 1/2 height times base 1 plus base 2. So we might need those area formulas. And if you look in the back of your notes, the very last page with your formulas, you'll see some area formulas that we're going to commonly use in this lesson. So in this case, we've got a triangle. Remember, the area of a triangle is 1/2 base times height. Well, you need to remember something about base and height of any figure that uses those measurements: triangles, trapezoids, and parallelograms. The base and height are always perpendicular to each other. Okay, so that's really important to remember. Okay, base is perpendicular to height. There's always a right angle there between base and height. So for a right triangle like this, the base can just be that side of the triangle 4. That could be your base. Which would make the height, this other segment, perpendicular to that, which actually is the side 3. That's your height in a right triangle. Now, I want you to make note of this. If the triangle is not a right triangle, the base would actually be a measurement like this, or sorry, the height would be a measurement like this, perpendicular to a base like that. Okay? But for our example, base and height are already sides. So the base is 4, the height would be 3. 4 times 3 is 12, and 1/2 of 12 is 6. So 6 square units is your area. So let's actually put this into practice. When we graph shapes in the coordinate plane, we can still find perimeter and area by using several different strategies for finding those lengths that we need for either length and width or base and height or radius, things like that. So in our first example, we are told that there is a triangle ABC with these coordinates: A, -4, 3, B, -4, -1, and C, 3, 3. And we're going to plot those points on the graph first to make our triangle. So A is at -4, positive 3. So remember, your x coordinate comes first. So that's from the origin to the left 4, up 3. There's A. Want to make sure we label with the letter. B is at -4, -1, so directly below A. And C is at positive 3, positive 3. So there's C. Now, when I make this connection, when I connect the sides, you'll see this is a right triangle. This works very well for me because anytime I have a right triangle, when I go to use area, the sides, the legs, make up the base and height. The other nice thing about this example is you'll notice that segment AB is vertical and segment AC is horizontal. For those lengths, we don't have to use distance formula or even Pythagorean theorem because we can just count those lengths. You can always count a vertical or horizontal measurement. So for AB, from A down to B is a length of 4. So the length of AB is 4. Okay, we're going to skip over BC and focus on CA for a second. CA across the top, that's horizontal, CA or AC. I can count that one as well. We can count from A over to C, and if you count that carefully, you should realize that is a length of 7. But to find the length of BC, that is a diagonal. We have to do this one of two ways. We can either use the distance formula with these ordered pairs, or we can use the Pythagorean theorem since we have the graph. And we already have a right triangle. Okay, so I can go ahead and use a squared plus b squared equals c squared. And for most of these, since we have graphs, we're going to use Pythagorean theorem a lot today. So to find c, that length c there, we're going to do a squared plus b squared equals c squared. So a, I'm going to call one of those legs 4. B is the other one 7. Okay, so when I square 4, 4 squared is 16. 7 squared is 49. Then I'm going to add those together. 49 plus 16 is 65. And then I take the square root of that. So when I do the square root of 65, we get about 8.062, and so we're going to round that to 8.1. And so that's the lengths that I need, because I have two things I have to find. I have to find the perimeter and area. So for the perimeter, I need all 3 sides. So I'm just going to add those up. Okay, for my perimeter, I'm going to add 4 plus 8.1 plus 7. Okay, when I add those together, I should get 19.1. So that's my perimeter of the triangle. For area, we're going to use the specific area formula. Area of any triangle is 1/2 base times height. Well, on our graph, one side I'm going to use for my base is actually this side, AC, because I already know it's 7. So that's 1/2 times the base 7. And then this segment AB is perpendicular, so that's the height, 4. And then I would just multiply 7 times 4 first, that's 28. 28 divided by 2 is 14. So that's how we find area and perimeter. Let's try another example like that. Number 2, same idea, we've got another triangle. Want to plot the points X, Y, and Z. X is at 4, 2. Y is at -2, 2. And Z is at 0, -4. That's on the y-axis down here at -4. So when I graph these lines and I get this triangle, you should notice this is a little different than the previous example. This triangle is not a right triangle. And it only has one side that is horizontal. There's no vertical sides. And so I'm going to have to use Pythagorean theorem for these other 2 sides, or the distance formula. But for that side that is horizontal from y across to x, I can count that. Again, I can count to find the length of xy. From y all the way over to x is a length of 6. So xy is just 6. Okay, we can count to get that. But to find these other 2 lengths, here's what I want you to do. I want you to think of this as 2 right triangles kind of stuck together. If I draw this segment and split the triangle vertically like this, you'll notice that creates a right triangle here. And then it also creates a right triangle here. So I can use Pythagorean theorem here to find those other 2 sides. Okay, I can find YZ by using Pythagorean theorem. One leg of that right triangle is 2. The other leg here in the middle is 6, if I count. Okay. So I can use those dimensions, 2 squared plus 6 squared equals c squared, to find the length of YZ. 2 squared is 4, 6 squared is 36. So I'm going to add those together now. 4 plus 36 is 40. And then we take the square root. The square root of 40 is about 6.3. Okay, so there's that side. I can even write it in if I want. For the perimeter, I need the other side still. So we're going to look at this triangle. Which has one leg. Don't get confused by that 6. That leg's only 4. And then it has the other leg also is still 6, from same as the other triangle. So I can use Pythagorean theorem again. 4 squared plus 6 squared equals c squared. 4 squared is 16. 6 squared is 36. So when I add those together, I get 52. Then we take the square root. And we get about 7.2 for that length. So to find my perimeter, okay, I'm going to add up those 3 sides. 6 plus 6.3 plus 7.2. When I add those together, I get about 19.5 for my perimeter. But for the area, remember, it's still a triangle. Area needs to be 1/2 base times height. So to find the area, I need to identify base and height. Well, anytime you have a horizontal segment of a triangle on a graph, we really want to use that as the base, because the vertical distance from that side to an opposite point will always give us the height. So this time I'm going to use my base of 6, and then my height is also 6 when I count that. Okay, that's that 6 right there. So base and height are both 6. So 1/2 of 6 times 6 gives me 1/2 times 36, or half of 36, which is 18. So that's the area of that triangle. Okay. If I get going too fast or you need to pause and kind of double check something, again, pause the video. But let's go ahead and go to the next examples then. Turn the page. This time we have a rectangle. Now, rectangles sometimes are a little more simple, but be careful how you graph this to make sure it still looks like a rectangle. So we're going to plot the points first. A is at -2, 4. There's A. B is at 2, 2. Not point 2, point B. Okay. C is at -1, -4. And D is at -5, -2. So it's kind of angled, slanted like this, but this is a rectangle. All right. So what I want us to do is find some lengths here. And I'm actually going to have you pause the video to find these lengths. All right. I want you to pause the video here, and I want you to find the lengths. Now, I will help you get started if you need some assistance. Let's say we started with point A. I'm going to use Pythagorean theorem or the distance formula. I'll probably use Pythagorean theorem most of the time here, though, because I can make that a right triangle where AB is the hypotenuse of that right triangle, where one leg is this vertical distance, 2. The other leg is the horizontal distance left to right, 4. So I can do 2 squared plus 4 squared equals c squared to find AB. So you're going to do something like that to find the length of all 4 sides. If you need more time, keep the video paused. Otherwise, these are the answers you should get. When you look at this, when we do our length of AB using the Pythagorean theorem, we get 4.5. And when we do this again for the length of BC, that little right triangle we draw has a horizontal length of 3 and a vertical length of 6. So we do 3 squared plus 6 squared equals c squared, and that gives you 6.7. Now, we only have to do those twice, or once each, okay? Because remember, it's a rectangle. Opposite sides of a rectangle are the same, congruent. So DC or CD is also 4.5, and AD is also 6.7. So you don't have to do a bunch of extra work. Now, if you did, that's okay. Hopefully you got the opposite sides are the same. All right, so now I can find the perimeter. To find the perimeter, we're going to add these together. So for perimeter, we do 4.5, and we're going to double that up because there's 2 of them, plus 2 of the 6.7s. When I add all that together, I get 22.4. Now for the area of a rectangle is base times height, or length times width. Okay, well, guess what? These numbers represent the length or width, and these represent the other ones. So if I call that the width, that's the length. I I would get 6.7 times 4.5. And my area is 30.15, but we're going to round that to 30.2. Okay? All right, a couple more. This time I give you a circle, and notice I didn't give you any coordinates to graph yourself because it's a circle, there's no vertices. And so I just graphed the circle for you. I want you to find the circumference and area of the circle. Well, for each of these, the formula uses pi and the radius. So, and I'll start with circumference. Circumference formula is 2 pi r. The area formula is pi r squared. So I need to know the radius of the circle for both. You should be able to look at this circle and realize this is my center. So from the center to a side gives me a radius of 2. So there's even a blank for it. The radius is 2. And then we're just plugging into the formulas. 2 pi times 2. And then for the other formula, that's pi times 2 squared. Now what you notice about this for circumference, I do my 2 times 2 first, then times pi, or if I put that all in the calculator at once, I get about 12.6. But you're going to get the same thing for the area in this case because we're doing 2 times 2 here and we're doing 2 squared. Both of those give you 4. So it's 4 pi for both of these. And then that's the same decimal answer, 12.6. All right, one final example. And in this example, I call it a hexagon, but this is not a regular hexagon. All these sides and angles are a little bit different. This is what we call an irregular shape. But we can still find the perimeter, and that's all I ask for this time is perimeter. We can still find the perimeter by adding up all the sides. Now, some of these sides are easy to count because they're either horizontal or vertical. Like from B to C is a length of 4. And then these other sides down here, from A down to F, if you count that, that's a length of 7. And from F over to E, if you count that one, that's also 7. So we have those measurements. So I'm going to fill in those blanks first. BC is 4. FA, the very last one, is 7. And EF, or FE, is also 7. So I have those 3. It's these other 3 sides that I have to find. AB is a slanted diagonal side. So think of that as part of a right triangle. I'm going to draw the right triangle like this. There's that right triangle that gives us that to do a squared plus b squared equals c squared. CD over here, okay, you can draw another right triangle. DE, I can do another right triangle. Use a different color. Okay. So the measurements we need to use for AB, there's a leg of 1, the other leg is 4. Make sure you're counting carefully. For this other triangle to find CD, that left to right leg is a length of 3, top to bottom leg is a length of 5. And this other small skinny triangle has a length of 1, and then from D all the way down to E vertically is a length of 6. So you're going to use Pythagorean Theorem again to find all 3 of these lengths. Okay? I want you to pause the video and finish out Pythagorean Theorem on these 3 lengths to find these and then go ahead and calculate the perimeter. If you need more time, keep the video paused. Otherwise, this is what we should get. All right, when you do the Pythagorean Theorem to find each one of these other lengths, AB, CD, and DE, these are what you should get. The length of AB is 4.1. The length of CD is about 5.8, and the length of DE is about 6.1. So when I add all of those together, I should get a total perimeter of 34. All right, now that finishes up our lesson on area and perimeter in the coordinate plane. Just really remember how to use that Pythagorean Theorem and really make sure you're counting lengths horizontally and vertically correctly. If you have any questions, make sure you let me know. Otherwise, you are ready to start the assignment.